Hello everyone, in this video we are going to learn about differentiation. Firstly, let's quickly recap the gradient function dy over dx equals to the lim h tends to 0 f bracket x plus h minus fx over h. Now let's try to use the gradient function to find the derivative of function x to the power of n. So we write down that the derivative of the function equals to the lim h tends to 0 fx plus h minus fx over h. That equals to the lim h tends to 0 x plus h to the power of n minus x to the power of n over h. Now let's expand this bracket. Remember that you need to use a factorial notation. So we have lim h tends to 0 x to the power of n plus n choose 1 x to the power of n minus 1 times h plus n choose 2 x to the power of n minus 2 h squared and so on until we have h to the power of n and minus x to the power of n over h. Now we can see that we can cancel x to the power of n, and then you need to divide by h. So what we have lim h tends to 0 n choose 1 x to the power of n minus 1 plus n choose 2 x to the power of n minus 2 h plus so on plus h to the power of n minus 1. Well, as h tends to 0, n choose 2 x to the power of n minus 2 h tends to 0. And you can see that any term includes h tends to 0. The only thing we have is that n choose 1 x to the power of n minus 1. So we write down that derivative fx equals to n choose 1 times x to the power of n minus 1. That equals to n factorial over 1 factorial times n minus 1 factorial x to the power of n minus 1. That equals to n times x to the power of n minus 1. Which means the derivative of x to the power of n is n times x to the power of n minus 1. Now, let us see how to find the derivative of function a times x to the power of n. So we still use the gradient function that we have the derivative of function equals to lim h tends to 0 f bracket x plus h minus fx over h. That equals to lim h tends to 0. We have a times x plus h to the power of n minus a x to the power of n over h. So similarly, we expand the bracket x plus h to the power of n. We have that a times x to the power of n plus n choose 1 x to the power of n minus 1 h plus n choose 2 times x to the power of n minus 2 h squared and plus so on until h to the power of n. Then we minus x. Then we minus a times x to the power of n and over h. So we have then h tends to 0, ax to the power of n plus n choose 1, a times x to the power of n minus 1, h plus n choose 2, a times x to the power of n minus 2 h squared, and plus so on, plus a h to the power of n minus ax to the power of n over h. We can see that we can cancel the term a times x to the power of n. And then we need to divide by h. So what we have lim h tends to 0, n choose 1, a times x to the power of n minus 1, plus n choose 2, a times x to the power of n minus 2h, plus so on, plus until a times h to the power of n minus 1. As h tends to 0, any term includes h tends to 0. Thus, what we left the derivative fx equals to n choose 1 a times x to the power of n minus 1. That equals to n factorial over 1 factorial times n minus 1 factorial a times x to the power of n minus 1 equals to an times x to the power of n minus 1. Therefore, we get that the derivative of a times x to the power of n equals to an times x to the power of n minus 1. So we have that for all real values of n and for constant a, if y equals to fx equals to x to the power of n, then the derivative fx equals to n times x to the power of n minus 1. If y equals to fx equals to a times x to the power of n, then the derivative of fx equals to an x to the power of n minus 1. Now, let us use this differentiation to do some questions. So question 1 said you need to find the derivative when fx equals to the following expression. So let's see, for part A, we have fx equals to x to the power of 5. Then the derivative equals to 5 times x to the power of 5 minus 1 equals to 5 times x to the power of 4. For part B, we have fx equals to x to the third, to the power of thirds. So the derivative of that equals to thirds times x to the power of thirds minus 1 equals to thirds times x to the power of minus 2 over 3. For part C, we have the function equals to x to the power of minus 2. The derivative of that equals to minus 2 times x to the power of minus 2 minus 1. That equals to minus 2 times x to the power of minus 3. For part D, we have function fx equals to 2 times x cubed. So the derivative of that equals to 2 times 3 times x to the power of 3 minus 1 equals to 6 times x squared. For part E, we have fx equals to 3x to the power of 4 over 2x. That equals to 3 over 2 x cubed. So the derivative of that equals to 3 over 2 times 3 times x to the power of 3 minus 1. That equals to 9 over 2 times x to the power of 2. For part F, we have function that the square root of 25 x to the power of 5. That equals to square root of 25 times x to the power of 5 to the power of half equals to 5 times x to the power of 5 over 2. Thus, the derivative of this function equals to 5 times 5 over 2 times x to the power of 5 over 2 minus 1 equals to 25 over 2 times x to the power of 3 over 2. Now let us see question 2. Given that 27 times y cubed minus x squared equals to 0 and y greater than 0, find the derivative of that. Find the dy over dx. So firstly, we need to write down the expression of y. Then we can rearrange this equation. We have 27y cubed minus x squared equals to 0, implies that 27y cubed equals to x squared. Thus, y cubed equals to 1 over 27 x squared. And then we cube root of that. So we have 1 over 27 x squared to the power of thirds. That equals to 1 over 27 to the power of thirds times x squared to the power of thirds. This, we have that 1 over 3 times x to the power of 2 over 3. So we have the expression of y in terms of x. Then we can find the derivative of that. So dy over dx equals to thirds times 2 over 3 times x to the power of 2 over 3 minus 1 equals to 2 over 9 times x to the power of negative thirds. Here is the answer. Okay, here is the end of the video. Thank you for your watching.